Okay, so in reaction number 3, okay, we have magnesium nitride. Right? It's going to break down into its component elements. That would be magnesium and nitrogen. All right, so I've done steps 1 and 2. I've identified the reaction type and I've decided what the products are going to be. Now I have to get the fine details of those products. They're both elements, so I don't have to do any swapping and dropping. But I need to look for special elements. Is magnesium a special element? No. Okay. Is nitrogen a special element? Yes. All right. How special? It's a 2. Okay, so now I've got that part right. Now I can look at my balancing. Looks like nitrogen's already balanced. It's 2 and 2. Okay, but there's 3 magnesiums on the reactant side, so I need a 3 over here. All right, so the big thing, guys, is anytime you get an element formed as a product, check to see if it's special. Okay, you got to check to see if it's special. Okay, let's have a look at number 2, because single replacement reactions have the worst track record for having to look for special elements. You have to swap and drop because you're going to have an ionic compound as a product. You have to do all of it. Okay, so they're the ones that present the most problems usually. Okay, so how do I know that that number 2 is a single replacement reaction? There's an ionic compound and an element. Okay, so in this ionic compound, sodium is my metal, nitrogen is my nonmetal. It's reacting, the element it's reacting with is magnesium, which is a metal or a nonmetal? Metal. All right, so who's magnesium going to switch places with? With sodium, right? Okay, they have to switch with what they're like. Okay, that's the part of the replacement reaction we have to remember. Okay, so that means that magnesium will end up with nitrogen and sodium will end up by itself. Okay, so I've done the first 2 steps. I've identified the type, I figured out who goes with who, and who ends up alone. All right, I have an ionic compound because it's a replacement reaction. Okay, so I need to drop and swap this compound. Nitrogen is a -3, magnesium is a +2. So the 3 comes here, and the 2 comes here. All right, so I've got Mg3N2 for magnesium nitride, same as I have in the next question. It's actually the start of the next question. And then I have sodium. Sodium's by itself, so I need to check if it's special. Is it? Is sodium one of our special elements? No, it's not. Okay, so I can leave it the way it is. All right, now I've got to go back and start balancing everything once I'm certain of my swaps and drops and special elements. So let's look at maybe, I could balance sodium right now. It's a 3, but that's not going to help me. Okay, because I'll put a 3 over here and then my nitrogens won't be balanced. And again, I could do the same thing with magnesium. I could put a 3 here, but that still doesn't balance my nitrogens. I'm going to end up having to change numbers. So I'm going to start with nitrogen and I'm going to put a 2 here to balance my nitrogen. Okay, everyone kind of follow my logic on that? Okay, so how many sodium do I have now? 10? 6. Okay, so I'm going to put a 6 over here. Okay, and so now I've got 2 nitrogens, I've got 6 sodiums, 6 sodiums, okay? I've got 3 magnesium over here. Now I've got 3 magnesium over here, and I'm done. Okay. All right, so the big thing here, guys, is remembering the simple stuff, because I think that's what we overlooked on the quiz, was the simple stuff, the special elements and the dropping and swapping and stuff like that. Okay, that's what kind of gave us trouble there. So I want you guys to try 1, 4, and 5 right now, and then we'll walk through those in a couple of minutes and see how we do. Okay? If you're having some trouble, call me over, okay? Okay, so the issue with number 1 is that it's a compound plus an element, which leads us sometimes to think, ooh, compound plus element means single replacement reaction. Except it's only a single replacement reaction if the compound is ionic. Okay, this isn't an ionic compound. This is a molecular compound. Carbon's not a metal, right? Okay, so if I have a molecular compound reacting with oxygen, especially one that contains carbon and hydrogen, this is a hydrocarbon combustion, which we just usually call combustion reaction. All right, so it's a combustion reaction. And what are always the products of a combustion reaction? CO2, and water. Okay, so that one can be tricky because the pattern kind of looks like another type of reaction. What we have to do is recognize that's not an ionic compound. All right, so now I've got carbon dioxide and water there. Now I need to balance. There's special balancing rules here, and I'm going to need them both because I have an even number of carbons, which I will balance first because I'm going to balance alphabetically. Okay, so first I'm going to put in the rule of 2. All right, so I'm going to have how many carbons here? How many? 4. Okay, so I've got 4 here. All right, 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. And now I can look at my oxygens. I have 8 oxygens in the carbon dioxide and another 6 in the water for a total of 14. 7 times 2 is 14. Okay. Now, here's the weird thing about that reaction. Had I written that reaction out in words, none of you would have misidentified it, because I would have written it like this. C2H6 burns in the presence of oxygen. Right? I wouldn't have written reacts with oxygen. I'd have said burns in the presence of oxygen, which would have right away said, oh, burning, combustion, and everyone would have identified it that way. Okay, so understand that you could get a question written like this, or you could get the question written out in words. They each present different challenges. Okay, that reaction written like this presents a challenge because of the pattern. Okay, if I write these reactions out in words, they present more of a challenge because now you have to also write the formulas for the reactants. Okay, so there's more chances that, oh, I forget a special element or I forget to drop and swap something. Okay, so they each present different challenges for you. All right, how many people are done number 4? Okay, let's have a look at that one. Okay, so in number 4, I have sodium permanganate and it's reacting with iron 2 sulfide. All right, so what kind of reaction is that? It's a double replacement reaction. These are both ionic compounds. They're metal and polyatomic ion, metal and non-metal. Okay, so they're definitely both ionic. Now, in a double replacement reaction, what happens to the metals? Liam, what happens to the metals? They switch places, exactly. All right, so that means that iron is going to end up with permanganate and sodium is going to end up with sulfur. All right, so I've now predicted who the partners are. There's no special elements here because I don't have any elements by themselves, but I have 2 ionic compounds that need to be dropped and swapped. Now, iron has more than one possible charge. How do I figure out what its charge is? Right, I look at it over here. This is the only way I'll figure it out. So over here, it was with sulfur, which is a -2. Right, so that means that this has to be the iron that has the +2 charge because they were 1 to 1. All right, so this is iron 2+. Permanganate is a -1, so I'll need brackets here and a 2 outside the brackets. And then I've got sodium, which is a +1, and sulfur, which is a -2. So I've got Na2S. All right, everybody with me on my swaps and drops? Right? If that's something that's still giving you a little bit of trouble, then that's something you definitely need to practice or come in and see me for some help on before the unit exam, because you've got to be able to do that, especially for the next thing we're going to learn. All right, so now that I've got everything dropped and swapped, now I need to look at balancing. 2 is my biggest number. It's on permanganate and sodium, so I'm going to go back over here and put a 2 there to balance them both. Now both sodium and permanganate are balanced on both sides. 1 iron, 1 sulfur, 1 sulfur. My reaction is good. Okay. All right. How many people are done 5? Okay, let's have a look at that one then. Okay, I've got copper reacting with fluorine. Element plus element is synthesis. All right, so this is going to make a single compound. What kind of compound is it going to make? It's going to make an ionic compound. One of them is a metal, the other is non-metal. Remember, this happened on the quiz yesterday. I flipped them and I put the metal second, and it caught a few people. All right, so metal always goes first in an ionic compound. Non-metal always goes second. Okay, copper's an element over here, but it's in a compound over here. I don't know what its charge is, and it has more than one. Which one do I go with? the most common, which is the first one listed, and that is 2+ on your periodic table. All right, so this is copper with the 2+ charge. Fluorine has a -1 charge, so when I drop and swap, I get CuF2. And now I'm done because it's already balanced. First one listed, so on the left. So in that case, it's 2+. Yeah? All right, is that making some sense? Okay. I'm gonna write out a couple in words and see how we do with those, okay? Because again, those present different challenges. Okay, I want you guys to try those ones. All right, so this time you're gonna have to write out the reactants first and then go through the steps, identify the reaction, etc. Okay, so I'll give you a few minutes on those ones. All right, so as I was saying before, okay, the challenge with this kind of a reaction is that we also have to get the reactants right now because they're not given to us. All right, so I have magnesium phosphide. So magnesium is Mg, phosphorus is P. Okay, phosphorus is a -3, magnesium is a +2. It's an ionic compound that I need to drop and swap. So I've got Mg3, P2 as my first reactant, and it's reacting with lithium. All right, so I've got my reactants written out. Lithium is not a special element, so it doesn't need any little numbers. All right, what kind of reaction am I looking at here? Jeremy, what kind of reaction is this? Single replacement. Okay, so this is a single replacement reaction, and my element is a metal. So lithium is going to switch with magnesium. All right, so that means lithium ends up in the compound with phosphorus, and magnesium ends up alone. All right, again, with single replacement reactions, we have lots of stuff to look for. We are going to have an ionic compound that needs to be dropped and swapped. That's our lithium with phosphorus. And we have an element by itself. Magnesium is not a special element, so it doesn't need any small numbers. Okay, but I have to drop and swap this compound. Lithium is a +1, okay, and phosphorus is a -3, so we just drop and swap, Li3P. Everybody all right with that? Okay, what's my last step? Balance the whole reaction. Okay, so right now, both magnesium and phosphorus, actually everything is out of balance right now. If I start with lithium, I'm going to end up changing it. How do I know that? How do I know that if I just take this 3, put it here, that I'm going to end up changing that in a minute? Right, because the phosphorus is also unbalanced, okay? And I'll have to put a 2 in front of that. So I'm going to do that first. I'm going to put a 2 here to make my phosphorus work. That's going to give me 6 lithiums. And I've got 3 magnesium on this side, but I only have 1 on the product side. So a 3 there will balance my magnesium. All right. Okay, how many people are done number 2? All right, I'm going to give you guys a couple more minutes here, and then we'll walk through 2 and 3. So for number 2, I've got sulfur reacting with potassium. Okay, so sulfur is S, it's reacting with potassium, which is K. All right. What kind of reaction starts out with 2 elements? Synthesis. All right. So I'm going to make a single compound here. Am I forgetting anything? Sulfur is a special element. Okay. Anytime I've got elements by themselves, I need to check and make sure that they are special or not. Sorry, check if they are special or not. Okay. Sulfur is very special. It comes as an 8. Okay. Potassium is not special at all. We're not saying that to hurt its feelings. It's just not. Okay. So it'll stay just as a 1. Now, when I combine these 2 things, potassium is a metal, sulfur is a nonmetal. They're going to make what kind of a compound? An ionic compound. So what do I write first, potassium or sulfur? Potassium. Okay, and again, that's one of those little tricks that's testing. In a question that's supposedly about reactions, I'm also testing if you remember your ionic compound formula writing rules. Okay, I can test lots of things in one question. All right, so K is going to end up with S, like so. Potassium is a +1, sulfur is a -2, so when we drop and swap, we're going to get K2S as our compound, so potassium sulfide. Now I need to balance the whole reaction, and it would probably be smart to start with sulfur because it's the biggest number, right? So I put an 8 there to balance my sulfur, and then I'll need 16 potassiums. All right, let's have a look at number 3 while we're here. All right, so what challenges does number 3 present us? What does it have lots of? Polyatomic ions. Okay, now those look intimidating, but you have to remember that polyatomic ions behave just like metals or nonmetals. Okay, depending on their charge. If they're negatively charged, they behave like a nonmetal. If they're ammonium, the only positively charged one we have, okay, it behaves like a metal. So I'm going to write this thing out. I've got ammonium, which is NH4, and it's in a compound with nitrate, which is NO3. Right? Definitely an ionic compound. Ammonium is a +1, nitrate's a -1, so that compound is okay the way I've written it. It's reacting with iron 3 sulfide. All right, what does that Roman numeral tell me? Cressa, what does that Roman numeral tell me? The charge on iron, right? Okay, so iron is a 3+ charge. Sulfur is a -2 charge, so we're going to get Fe2S3. Okay, so what kind of a reaction am I looking at? Andrew, what kind of reaction is this? It's a double replacement reaction. Okay, so who is going to end up with sulfur on the other side? Ammonium is going to end up with sulfur. All right, so I'm going to put that down first, NH4 with S. And that means that iron has to end up with nitrate. All right, so I've got the partners figured out. I've got the metals listed first and the non-metals listed second, okay, just like I'm supposed to in an ionic compound. What do I have to do with these ionic compounds? I got to drop and swap them. Am I probably going to need brackets? And that's another thing we always have to remember. Okay, when we're dropping and swapping ionic compounds and they have polyatomic ions, we sometimes need brackets. Okay, ammonium's a +1, sulfur's a -2, so I'm going to put brackets around the ammonium with a 2 outside the brackets. Iron, we found out, was a +3 from the name. Nitrate's a -1. So I'm going to need brackets with a 3 outside the brackets. Okay. All right, so now I've done my swapping and dropping. Now I need to balance the whole reaction. Okay, so this is going to be a bit of a nightmare because I think I picked something that's not going to work. All right, so I've got, this is going to be a tricky one. So I've got 2 ammoniums over here. I only have 1 over here. The problem is that over there, I have 3 nitrates. I need to put a number in front of this that balances both of them at the same time. You guys follow me here? What number is going to, okay, so sorry, Stan, where did I lose you? Everywhere? Okay, so on this side, I have 1 ammonium and 1 nitrate, right? They work out that way. But over here, I have 2 ammoniums and 3 nitrates, right? So I've got to find a number that's going to balance them both that I can put in front of this compound. What is it? 6, yeah. Okay, so I'm going to put a 6 here. So now I have 6 ammoniums. I go back over here and make sure I have 6 ammoniums. That just so happens to make my sulfurs work, so that's a good sign. Okay, because now I have 3 sulfurs on the reactants and 3 on the products. Okay, now I've got to go here and give myself 6 nitrates by putting a 2 here. And, good sign, that's how many iron I have over here. All right, so that doesn't happen very often, but once in a while. Okay, and we got to recognize when it does. Okay, is this seeming a little more like, as long as you follow the steps, guys, you really can't go wrong. Okay, and it's always the same steps. Write it out, write out the reactants, identify the type, put the products together, swap and drop, look for specials, balance the reaction. Always the same steps. Okay, we follow those, we should be good as long as we're, remembering those 2 steps that were giving us trouble before, the specials and the swaps and drops. Okay. All right, I want you guys to try. Let's have you try just the first 5 on here for right now. Okay. So with number 1, I have C8H18, which is octane, reacting with oxygen. If I was writing this out, what word would I use instead of reacts? Burns. Yeah, I would say that octane burns in the presence of oxygen. Okay, anytime you've got C something, H something, and oxygen, it's a combustion reaction. Always, always. Okay, and we said that writing it this way presents that challenge of, is that single replacement or is it combustion? Okay, if it's carbon, hydrogen, and oxygen, it's combustion. Okay, all right. What are the products always of a combustion reaction? Yes. Right, H2O and CO2. Okay. My special balancing rules. Okay, actually, sorry. Do I need to swap and drop any of those? No, because they're all molecular. Okay, carbon dioxide and water. Okay, I don't have to worry about those. And I have no special elements being produced over there. All right, so now I need to balance. And I have an even number of carbons, so I need to start with a 2. So 2 times 8 is 16. Then I need to balance my hydrogens. 2 times 18 is 36. Okay, so 18 times 2 is 36. I've got 32 oxygens here, plus another 18 here, adds up to 50. All right, what times 2 will give me 50? 25. Okay, so that's how that one should look. So to give you an idea here, guys, like on a unit exam, your questions are going to be very similar to what you've seen thus far. Okay, I would have a couple of questions that would be, here's the full reaction written out in words, you write it in formula form and balance it. Okay, and then I would have one written out in words that is, here's the reactants, predict the products and balance it. So write it out in formula form, predict and balance. That's what you're going to get. Okay, so that's what we got to kind of be ready for. How many people are done number 2? Okay, let's have a look at that one too. All right, so I've got sodium phosphate, and it's reacting with lithium oxide. Right, both of those compounds are ionic, so this is what kind of reaction? It's double replacement. So in the double replacement reaction, I need to swap the metals. So that means that lithium's new partner will be phosphate, and sodium's new partner will be oxygen. What do I have to do with both of those compounds? Jeremy, what do I have to do with those? Swap and drop them, exactly. All right, so lithium is a +1 and phosphate's a -2, right? minus 3. Sorry, minus 3. I always forget that one. Okay, so when I drop and swap, I'm going to Li3PO4. Okay, and then I have to do the same thing with sodium oxide. This is a +1. This is a -2. So we got Na2O. Okay, now I need to go back and start my balancing here. So I am thinking here that I probably need to start with maybe with sodium, I would say. Okay, on this side I've got 3, and on that side I've got 2. Lowest common multiple would be 6. Okay, so on this side I'm going to put a 2 here, and on this side I'm going to put a 3 here. Okay, when I do that, it balances my sodiums, but now I have 3 oxygens over here. So I'm going to go back over here and put a 3 in front of lithium oxide. That gives me how many lithiums? 6. Okay, so what do I need to put here in front of lithium phosphate? A 2. Okay, but that gives me 2 phosphates. Oh, well, how about that? I got 2 phosphates over here. Okay, always a good sign. All right, keep her going. I'll give you a couple more minutes and we'll go through 3 and 4. All right, let's look at number 3 here. Okay, so on number 3, I've got phosphorus, which is a nonmetal and an element, reacting with calcium nitride, which is an ionic compound. All right, so what kind of reaction am I looking at here? Tell you. Yeah, single replacement. Okay, I've got an element, okay, reacting with an ionic compound. That element is a nonmetal, so it's going to switch places with the nonmetal in the ionic compound. All right, so we're going to have that nitrogen is now going to be alone, and calcium is going to be with phosphorus. All right, always with single replacement reactions, got to check for special elements, and I've got to drop and swap. Nitrogen is a special element, comes as a 2. Calcium phosphide is an ionic compound. Okay, phosphorus is a -3. Okay, and calcium is a +2. All right, so we're going to have Ca3P2. Okay, for our drop and swap. Now we've got to balance the whole reaction. All right, I would say probably need to balance phosphorus first. Okay, if I was going to choose, because actually right now it's the only thing that's not balanced. But as soon as I balance it, okay, I'm going to screw a lot of other things up. Okay, so I've got 4 phosphorus over here, and I only have 2 over here. So I'm going to put a 2 in front of that. That'll balance my phosphorus. Okay, but that gives me 6 calcium, so I have to go back over here and put a 2 in front of this. Okay, when I do that, my calcium work, but now I have 4 nitrogens, so I need a 2 in front of that. All right, is that making some sense? All right, how many people are done 4 and number 4? All right, how many people are done 5? Let's have a look at those 2 then. All right, so number 4 here, I've got chlorine reacting with potassium. Okay, so element reacting with another element, so that is what kind of reaction? It's a synthesis reaction. Okay, what kind of compound is it going to make? Ionic. Okay. Potassium's a metal. So again, that trick again, right? Okay, I have to remember that metals go first, non-metals go second. Okay, and I've got to drop and swap. This is a -1, that's a +1, so that's dropped and swapped correctly already. Okay, all I have to do now is balance the whole reaction. So putting a 2 there will balance my chlorines, and a 2 there will balance my potassium. All right, last one, number 5 here. Okay, we got sulfur. Actually, we have disulfur trioxide. So what kind of compound is that? It's molecular. All right, it's the only reactant, so the only thing that can happen here is for it to do what? Decompose, okay? And when we decompose, we break down into our individual parts. So S and O. Okay, is sulfur a special element? Yes, comes as an 8. Is oxygen a special element? Yes, comes as a 2. All right, so now that we've got the special elements sorted out, I don't have any compounds to drop and swap, so I don't have to worry about that. I just need to balance everything. All right, generally we go with the biggest number, okay? If I've got an 8 here, I would need to put a 4 here in order to balance my sulfurs. All right, but that's going to give me 12 oxygens, so I need to put a 6 in front of that to balance it. Okay. Making sense? All right. Tomorrow, you are going to get an assignment on reactions after our quiz. Okay, so we'll have a quiz where we'll have a few prediction problems, and then I'm going to give you an assignment that I will give you the whole period to work on. Okay, it's 30 reactions. You're going to hand it in for marks. Okay, I know 30 right now sounds kind of intimidating, but trust me, it's going to go pretty quickly. Okay, so that's what we're going to be working on tomorrow. That'll be due sometime late next week. Okay, so that I can mark it and give it back to you so you can use it to study for your unit exam. Right. Now, in regards to your unit exam,